guy, basically reached out and says, "Look, I'm in the military, and I might be able to help prove the Earth is not a globe, not a sphere, could be flat, and he's got stuff to back it up. So it is my personal pleasure to introduce an active member of the United States Navy. His name is Robert. He is a NATO Sea Sparrow, and correct me as I'm doing this, NATO Sea Sparrow Surface Missile System Instructor. He's a master training specialist. And he's here, tonight to confirm three things, for this movement. One is, from everything he has observed during the last tour, there is nothing, absolutely no curvature to the Earth that he can determine. Two, there is no Coriolis effect taken into account with the ranged weapon systems he has been working with over the years. Three, the navigation systems currently being used by the United States Navy on the high seas, when you compare them to basic trigonometry, and he'll break it down for you, seem to be completely wrong. And there's many other points besides that. And wow, I'm just blown away that he is here. Robert, are you there with us?
I was in the same crowd as everybody else at one point, where I was kind of, the naysayer, like, oh, let me go ahead and show them all these quote unquote proofs that I have that makes them crazy. And
So you started as a debunker like everybody else.
pretty much, I really, I came into it with a really bad attitude, basically going on, the lines of, oh, I already know this, I know because someone told me.
On the seas, that there were certain things that were going on that didn't make sense to you. And I kind of wanted to go through them one by one. The first thing was you were mentioning to me about ships that you tracked in the distance. It's okay.
For anyone that doesn't know, max observable distance, roughly, for the horizon out to sea is about 15 to 18 nautical miles, depending upon humidity and dew point and all of that. I've actually been outside with binoculars, with high-powered telescopic devices. We have access to certain things like that. And as a ship is perceived to be dropping below the quote-unquote horizon, all you got to do is zoom in on it, and all of a sudden, poof, the bottom of the ship where it meets the water is back in observance again. And this doesn't add up, because at 15 nautical miles, there's several feet to be dropped around a curved Earth.
Yeah.
So it just doesn't add up at all. Our fire control radar, we actually use a 2-degree pencil beam. It's very, very tight beam, so there's very little room for deviation on that, and it's a direct line of sight radar.
Okay.
And we're able to track targets up to 50 nautical miles away, and on a curved Earth, that just doesn't add up.
Followed the Chicago skyline.
I have 60 miles away across Lake Michigan. Yep, they can see the whole city.
There you go. So this is collaborating that, which he's saying he can track targets at 50 miles away, which should be about 1,700 if you round up, 1,700 feet below the horizon. But you're hitting them just fine. Wow.
And we're tracking them just fine, and it just doesn't add up. You can do simple trigonometry on it with elevation angle, and everything works out, and you don't drop the track. You can track it quite a bit of a distance out.
We're talking about line of sight targeting or GPS for the projectile, for the missile.
For the missile, it's line of sight targeting. That basically, like I said earlier, we track the target with a illuminator, and it's basically just another piece of gear that's tied into ours. And once we lock up on the target, we're line of sight pointing straight at it, because it's a 2-degree pencil beam. It has to be pointing straight at it, because if it's not going to see it. It's not a search radar. It's a fire control radar. If you're supposedly looking at something, 50 nautical miles away around a huge curve, it's just you can't punch through the ocean with RF.
But the point is that the 2-inch beam, you have to have it on there for most of the trip. That thing's
Not
out
most,
there.
all of it, pretty much.
Okay, all the trip, except for the last couple seconds, if that. You can pull it off if you had to.
If you absolutely had to, but you have to understand, if it's not close enough, if you pull it off, the missile will go ballistic on its last update, and it might not hit the target.
Ah, got it. And so yeah, if and what you're basically saying is this 2-inch beam, what you're painting the target with, is you guys when you're firing this thing out there, you do not account for curvature. That beam shouldn't be able to reach a target at a certain at whatever the at 50 miles should not be able to hit that target.
Yeah, and this is a perfect thing, and I'm really glad that I was fortunate enough to work on this, because the argument always is, well, we can reach over a curve because we're a search radar and we use atmospherics and bounce off different parts of the atmosphere, and then
Okay.
it comes back down.
Okay.
Now, see, the problem with that is this can't happen with a 2-degree pencil beam. The angle of this cannot put RF up into an atmosphere and then bounce it back down and then expect to get it back so
It's
we
too
can properly track.
it's too
It's too
precise.
precise.
Yeah.
It's too precise. It can't
Yeah.
do that.
Yeah. Wow.
Last little topic that I
Sure.
wanted to mention about that
Mhm.
specifically is some of our search radars boast distances of being able to track stuff like over 200 miles away. So take that into consideration for supposed curvature. This is something to think about.
200 miles. Yeah, I haven't even looked at the thing at 200 miles, but that's a massive distance. That's I think that's a full-blown mile below the horizon if the world was actually round,
Mhm.
if I'm not mistaken. Which yeah, you shouldn't be able to hit it. Should not, unless again what you're talking about, bouncing it off something, which what you're saying it does not do. Let me ask something else, because you and I hadn't really. And again, if you can't talk about that, that's fine. But yeah, you specialize in the Sea Sparrow surface missile system, but you probably have had exposure to all sorts of different weapon systems from the ship point of view, both short range and maybe even a few that are longer range. Do you guys compare notes? I mean, do you kind of see the same sort of thing where everything's consistent? It's not like all the one system is using curvature and the other system isn't. Nobody's using curvature on anything, as far as you know.
As far as I know, we do not. Actually on I'm glad you mentioned that, because other systems, if you want to compare them, the
Mhm.
only thing we feed into our systems at all, and it's only on a plane system. We have this piece of equipment, and I'm sure quite a few people are familiar with this, but we use gyros, right?
Okay. Yeah.
And these gyros are powered on our ship, and basically they stay stationary once they're spooled up, and we have to power them up before we get underway.
Yeah.
And this information from this gyro is fed into all of our radar systems and all of our weapon systems, and all they account for is the pitch and roll of our ship. So we
Yeah.
can account and send that information to, compensate. Like if our ship takes a huge roll,
Yeah.
it compensates our weapon system to aim higher,
Hmm.
if need be. And if you look at the coordinate system for that, there's no curvature in that at
Yeah.
all. It's just a plain model.
That's great.
Wow.
So yeah, so basically what he's saying there, folks, in case you've missed anything yet, is that there are no weapon systems currently in the U.S. Navy that are using curvature, or the Coriolis effect. It is something we've suspected for a little while now, but nobody's actually said it.